7.4 goes over quotients, powers, and rationalizing denominators. The first thing that we're going to be looking at is rationalizing a denominator. When you rationalize a denominator, it just means that you have a fraction, that you have a radical in the denominator, and you have to get that radical out of the denominator. You cannot ever have a fraction that is in simplest form with a radical in the denominator. So in order to rationalize these denominators, we're going to pay attention to the index that's attached to the radical and multiply that radical by itself the amount of times that the index tells us. So if we look at example 1a, we have the square root of 3 over the square root of 5. The denominator here is the square root of 5. First, you look at this and you see you can't simplify either of those radicals. So then, again, you look at your denominator. You have the square root of 5. The index on that square root is a 2. So it tells you you need to multiply that square root of 5 by itself twice. You already have 1, so multiply it by itself. What you do to the bottom, you have to do to the top. So multiply the top and the bottom by the square root of 5. This gives us the square root of 3 times 5 all over the square root of 5 times 5. Again, you need a pair, so 2 of the same number in order to pull 1 out of a square root. On the top, you don't have 2 3s, you don't have 2 5s, so multiply those together. We get the square root of 15. On the bottom, you have 2 5s, so pull 1 out. We just have the square root of 15 over 5. And that is in simplest form because you cannot simplify something that is a radical over a whole number. That radical does not simplify. For example, B, we have 3 over the cube root of 2. For this one, in the denominator, we have the cube root of 2. That cube root of 2 cannot be simplified. So look at your index. Your index is 3. So we need to multiply the cube root of 2 by itself a total of 3 times. So we're going to multiply by the cube root of 2 times the cube root of 2. You multiplied 2 times on the bottom that you're adding in. Do the same to the numerator. So multiply the 3 by the cube root of 2 times the cube root of 2. When you multiply this out, on the top we're going to have 3 cube root 2 times 2. In the denominator, you have the cube root of 2 times 2 times 2. In the numerator, 3 times the cube root of 2 times 2 is just 3 cube root 4. In the denominator, you have 3 of the same number, so pull 1 out. You just have the 2. Check to see if you can simplify this. 3 cube root 4 over 2 cannot be simplified any further, so that is your answer. So by rationalizing these denominators, we're actually just eliminating the radical in the denominator. So it's just rewritten as a fraction with no radical in the denominator. For the next set of our notes, we're just simplifying these fractions, again, with our radicals in the denominator. So look at example A. For example 2, we have the square root of 10 over the square root of 6. If we take the factors of 10, that's 2 and 5. If we take the factors of 6, that's 2 and 3. So we can rewrite this as the square root of 2 times 5 over the square root of 2 times 3. This is the same exact thing as saying the square root of 2 times the square root of 5 over the square root of 2 times the square root of 3. In this case, your square roots of 2 cancel out, so you just are working with the square root of 5 over the square root of 3. Once again, we have a simplified fraction where we have a radical in the denominator. You cannot leave that radical in the denominator, so rationalize your denominator now. The square root of 5 over the square root of 3. Your radical in the denominator is the square root of 3. Your index is 2, so you need to multiply it by itself a total of 2 times. So we're going to multiply the square root of 3 by the square root of 3 as well as the square root of 5 by the square root of 3. So this is going to give us the square root of 5 times 3 over the square root of 3 times 3. Again, you need 2 of the same number to pull 1 out. So that's going to be the square root of 15 over 3. For example B, we have the cube root of 5 over 9. So this is the same exact thing as saying the cube root of 5 over the cube root of 9. You cannot simplify the cube root of the 5 or the cube root of 9. So take your denominator, which is the cube root of 9, look at your index, it's a 3. You need to multiply it by itself a total of 3 times. So we're going to have the cube root of 9 times the cube root of 9. You're going to do the same thing up top. So the cube root of 9 times the cube root of 9. Now when you do this, you're going to have the cube root of 5 times 9 times 9 all over the cube root of 9 times 9 times 9. In our denominator, we have 3 of the same number, so they group up and we pull 1 out. So our denominator is just going to be that 9. However, in the numerator, you have 5 times 9 times 9. No, those two 9s do not group up in order to pull 1 out. However, they are not factored out completely. The 9 is 3 times 3. So each of these 9s we can rewrite saying this is the cube root of 5 times 3 times 3 times 3 times 3. This will make it to where you don't have to multiply out the 5 times 9 times 9 and work with that large number. So if we're looking for groups of 3, you have 3 3s. You're going to pull 1 out. So you're going to have 3 cube root 5 times 3 all over 9. From here, we can still simplify inside the radical by multiplying the 5 times 3, as well as reducing the fraction because of the 3 and the 9 are both divisible by 3. I'm going to multiply inside first. This is going to give me 3 cube root 15 all over 9. From here, the 3 and the 9 are both divisible by 3, so the 3 becomes a 1, 9 becomes a 3. So we're going to have the cube root of 15 over 3. For our next set of examples, we're just simplifying each expression and assuming all variables represent positive real numbers. So for example, 3a, we have the square root of a over b. Again, rewrite this as the square root of a over the square root of b. Rationalize your denominator. You have the square root, so their index is 2. You need to multiply the square root of b a total of 2 times by itself. So we're going to multiply the square root of b by the square root of b, as well as the square root of a by the square root of b. We multiply these, we have the square root of a times b all over the square root of b times b. In the denominator, your two b's pair up. So this is going to give us the square root of ab all over b. For example, b, we have the square root of x cubed over y to the 5th power. Again, if we rewrite this, we have the square root of x cubed over the square root of y to the 5th power. We can simplify these by having x square root x over y squared square root y. The only thing that I did with that was I divided each of these numbers by our index, which is 2. On the top, I have x to the 1st power with the remainder of 1. On the bottom, I have y to the 2nd power with the remainder of 1. So the x to the 1st power goes on the outside. The remainder of 1 gives me an x on the inside. The y squared goes on the outside. The y with the remainder of 1 goes on the inside. So y goes on the inside. From here, I do have to rationalize my denominator. If I rationalize my denominator, I'm going to multiply the top and the bottom by the square root of y. So this gives us x square root x times y all over y squared times the square root of y times y. Two y's pair up. We bring 1 out. So we have x square root xy, because the x times the y cannot simplify, so we just multiply them, and y squared times y. From here, we multiply the y squared times y. and we're left with x square root xy all over y cubed. For example C, we have the cube root of x over y. So again, we have the same thing as saying the cube root of x over the cube root of y. We're going to multiply the top and the bottom by the cube root of y times the cube root of y. This is going to leave us with the cube root of x times y all over the cube root of y times itself 3 times. We group up sets of 3 since our index is 3. So this is leaving us with the cube root of x y squared over y. For the next set of examples that we are going to be looking at, we are going to be dividing radicals. When we divide radicals, we can put them in fraction form and simplify them that way. It's the same exact thing, and it's the easiest way to do this. So if we look at example 4a, we have the square root of 10 divided by the square root of 5. This can be written as the square root of 10 over the square root of 5. That 10 has factors of 2 and 5, so I'm just going to rewrite it as the square root of 2 times 5 over the square root of 5. This then can separate to be the square root of 2 times the square root of 5 all over the square root of 5. Your square root of 5's cancel, so we're left with the square root of 2. For example B, we have 3 square root 2 divided by 2 square root 3. So this one we're going to rewrite just as a fraction, so we have 3 square root 2 over 2 square root 3. We're going to multiply the top and the bottom by the square root of 3. So we're going to get 3 square root 2 times 3 all over 2 square root 3 times 3. Our group of 2 3's pair up, so this becomes 3 times the square root of 6 over 2 times 3. The 3's would cancel. You could also multiply the 2 times the 3 to get 6. It would still simplify from there, so this just leaves us with the square root of 6 over 2. The next part of your lesson, or no, sorry, example C. We still have one more example in this part. All right, so for example C, we have the cube root of 10x squared divided by the cube root of 5x. So we're going to rewrite this as the cube root of 10x squared over the cube root of 5x. From here, we can just multiply if you'd like to instead of simplifying. You could also simplify. It's totally up to you. When you see this, you have the cube root of 10x squared over 5x. It's the same exact thing as what we just wrote. The 5 would become a 1, making the 10 a 2, and the x would cancel out, making the x squared an x. So this is the same exact thing as saying the cube root of 2x over 1. So that's just the cube root of 2x, sorry. Okay, so think about it that way. And then let's multiply it to see the difference between the two. If we multiply the cube root of 5x by itself 3 times and do the same to the numerator, I'm going to rewrite this as saying the cube root of 10x squared times 5x all over the cube root of 5x times 5x times 5x. In the denominator, those 5x's group up, so you just have the 5x. In the numerator, that 10x squared is the same thing as saying 2x times 5x, which when you do this, you would write the cube root of 2x times 5x times 5x times 5x. Your 5x's group up. So this is 5x times the cube root of 2x all over 5x. Those 5x's cancel, so we're just left with the cube root of 2x. This is just another way of doing it. You get the same answer both ways. It's totally up to you which way you want to do it. If it was up to me, I'd write it the first way. It's a lot simpler and much quicker to do, but again, you get the same exact answer either way. Now for the next set of your examples. For example 5, we have the square root of 2 divided by the square root of 72x. Again, we have the square root for both, so we can rewrite this as saying 12 over 72x underneath the radical. The 12 and the 72 can simplify because they're both divisible by 12. The 72 divided by 12 gives us 6, and 12 divided by 12 is 1. So this is the same exact thing as saying the square root of 1 over the square root of 6x. We're going to multiply top and bottom by the square root of 6x to rationalize this denominator. Remember, the square root of 1 is just 1. So we're just going to have the square root of 6x over the square root of 6x times 6x. Those 6x's group up. So we're going to have the square root of 6x over 6x. We have the fourth root of 16a divided by the fourth root of a to the fifth, for example, b. I'm going to rewrite this as just saying we have the fourth root of 16a over a to the fifth power. I'm going to simplify this, that a to the fifth power. I'm going to subtract 1 from it and cancel out the 1 on top. So this is just the fourth root of 16 over the fourth root of a to the fourth power. Well, the fourth root of a to the fourth power just gives us a, and 16 is 4 times 4. The 4 is 2 times 2. We need a group of 4. The 4 2's pair up or group up. We pull 1 out. So it's just 2 over a. For example 6, we are just simplifying these fractions. For example A, we have 4 minus the square root of 12 all over 4. Now that square root of 12 you are going to have to simplify first. The 12 is 4 times 3. The 4 is 2 times 2. Those 2's are going to pair up. You'll bring 1 out. So this is 4 minus 2 square root 3 all over 4. You'll see that this 4 up top, the negative 2, and the 4 on the bottom are all divisible by 2. So we are going to divide each of those numbers by 2. When we do this, that 4 is going to turn into a 2, the negative 2 turns into a negative 1, and the 4 on the bottom turns into a 2 as well. So we have 2 minus 1 square root 3, which is just negative square root 3, all over 2. For example B, we have negative 6 plus the square root of 20 all over negative 2. For this one, again, simplify that square root of 20 first before you do anything else. That square root of 20 is 2 and 10. The 10 is 2 and 5. So those two 2's pair up. You bring 1 out. This gives us negative 6 plus 2 square root 5 all over negative 2. Now there's two things that you have to do here. You have to pay attention to this sign. That negative in the denominator cannot be in the denominator, so simplify that first. You're going to switch the sign on every term. So this is going to be a positive 6 minus 2 square root 5 all over 2. Now you realize that the 6, the negative 2, and the 2 in the denominator all have a common factor of 2, so divide them all by 2. 2 in the denominator becomes 1, the negative 2 up top becomes negative 1. The 6 becomes 3. So that's just 3 minus 1 square root 5, so 3 minus the square root of 5. For the next part of our lesson, we're going to be rationalizing denominators using conjugates. Conjugates, you're going to look at the denominator of these fractions. They're going to have an expression like a binomial that contains a radical. If that is the case, you have to multiply the top and the bottom of that fraction by the conjugate of the denominator. The conjugate of the denominator, you're going to keep both terms but switch the sign between them. So if you look at example A, we have 2 plus the square root of 3 all over 4 minus the square root of 3. In order to get the conjugate of your denominator, that 4 minus the square root of 3, we're going to keep the 4, we're going to keep the square root of 3, but we're going to change the sign between them. So instead of it being a negative, it's going to be a positive. And we're going to multiply it to the bottom and to the top of that fraction. When we do this, we just FOIL it out. The bottom, however, is a difference of squares, so you can take the first term, which is 4, and square it, minus the second term, which is the square root of 3, and square that, and then just simplify. If we are to FOIL, though, up top, you have the 2 times the 4, which gives us 8. 2 times the square root of 3 is 2 square root 3. The square root of 3 times 4 is 4 square root 3. And the square root of 3 times the square root of 3 is the square root of 9. In your denominator, the 4 times 4 gives us 16. 4 times the square root of 3 is 4 square root 3. Negative square root 3 times 4 is negative 4 square root 3. And negative square root 3 times times the positive square root 3 is a negative square root 9. From here, we simplify. In the numerator, simplify the square root of 9 and combine your like terms. This is going to give us 8 plus 6 square root 3 plus 3. In the denominator, your like terms cancel each other out since they're opposites. And the square root of 9 is 3, so that's 16 minus 3. Up top, combine your like terms. On the bottom, combine your like terms. 8 plus 3 gives us 11 plus 6 square root 3 all over 16 minus 3 is 13. Check to see if you can simplify this. Do you have a common factor other than 1 that goes into the 11, the 6, and the 13? You do not, so 11 plus 6 square root 3 all over 13 is your answer for this one. For example B, we have the square root of 5 over the square root of 6 plus the square root of 2. If you look at the denominator, you have the square root of 6 plus the square root of 2. You cannot simplify that square root of 6 because its only factors are 2 and 3, and the 2 doesn't pair up with another 2, nor does the 3 pair up with another 3. So we're going to multiply the top and the bottom of this fraction by the conjugate of your denominator. So keep the square root of 6, keep the square root of 2, change the sign between them. You have the square root of 6 minus the square root of 2 that you're multiplying on the top and the bottom of this fraction. Distribute in the square root of 5 into the numerator. So you have the square root of 5 times the square root of 6, which is the square root of 30, minus the square root of 5 times the square root of 2 is the square root of 10. In the denominator, like we said before, it's a difference of squares. So you can take the first term, which is the square root of 6, and square it, minus the second term, which is the square root of 2, and square that. From here, we simplify. Up top, the 30 and the 10, you cannot simplify those. The 30, your factors are 2, 3, and 5. None of them pair up with another 2, 3, or 5, so leave it the square root of 30. Same thing with the square root of 10. Your only factors are 2 and 5, so keep it the square root of 10. The square root of 6 squared is 6. The square root of 2 squared is 2. So in the denominator, you have that 6 minus 2, which simplifies the whole thing to be the square root of 30 minus the square root of 10 all over 4. For our last part of this lesson, we are simplifying, and it's told to us that we are to assume that all variables represent positive numbers. So if we look at example A, we have 5 square root 2 all raised to the third power. When that's in parentheses, that power goes to every part of what's in the parentheses. So it's not just going to the square root of 2, but it's also going to the 5. So we're going to have 5 cubed and the square root of 2 cubed. The 5 cubed, multiply it out. 5 times 5 is 25, times 5 is 125. The the square root of 2 cubed is the same thing as saying the square root of 2 to the third power. That 2 to the third power gives us 8, so we have 125 times the square root of 8. Now that 8 is 2 times 4. The 4 is 2 times 2. So we would pair up a group of 2's, bring it out. We have 125 times 2 square root 2, and we just multiply the 125 times 2, and we get 250 square root 2. For example B, we have 2 square root x cubed, all raised to the 4th power. So this is the same thing as saying 2 to the 4th power times the square root of x cubed to the 4th power. Now, if you do this correctly, that 2 to the 4th power is going to give us 16. That x cubed underneath, that's being raised to the 4th power. So it's the same thing as saying the square root of x cubed to the 4th power. And when we have a power raised to a power, we multiply those. So we're going to have 16 times the square root of x to the 12th power. Our invisible index here is 2, so if we divide that 12 by 2, it gives us x to the 6th power. So we just have 16x to the 6th power. For example C, we have 3w times the cube root of 2w, all raised to the 3rd power. So when you do this, you're going to have the 3w raised to the 3rd power, as well as the cube root of 2w raised to the 3rd power. When your index and your power are the same, they cancel each other out. So it's just giving you 2w. That 3w cubed, we're going to take the 3 and cube it, as well as the w cubed. The 3 cubed gives us 27. W cubed is w cubed. We multiply that by 2w, and we're going to have 27 times 2, which is 54, and w cubed times w, which is w to the 4th power. For example D, we have 2t times the 4th root of 3t, all to the 3rd power. So we're going to do the 2t to the 3rd power and the 4th root of 3t to the 3rd power. For this, the 2 gets raised to the 3rd power, t gets raised to the 3rd power, and you also have the 4th root of 3t to the 3rd power. To simplify this, 2 cubed is 8, t cubed is t cubed. The 4th root of 3t cubed is going to be 27t cubed. The factors of that 27 are just 3 times 3 times 3. You do not have 4 of the same term or the same number for either the t cubed or the 27, so you leave it 8t cubed times the 4th root of 27t cubed.